With our backs to the wall, the darkness will fall. We never quite thought we could lose it all. Ready, aim, fire. Ready, aim, fire. An empire's falling just one day. You'll close your eyes and the glory fades. Ready, aim.
Hi scholars, we're going to talk about proportions today. So first off, what is a proportion? So a proportion is very simply an equality between two different fractions or rational numbers, right? So in general, we can say any proportion, you can write it as an equality, so there's always going to be an equal sign in the middle here. And we're going to say that one fraction is equal to another fraction, right? And so fractions, we've learned that they're a little different from natural numbers and from integers because there's many different ways of writing the exact same fraction. For example, if I have the fraction 2/3, that is the same, it is identical to the fraction, let's say 8/12, right? And the question is, well, this is a claim, right? We're saying these two fractions are equal to each other. Is there any way we could check it, we could verify it? And yeah, certainly, that's where the cross multiplication comes in. When you cross multiply, which you can do with a proportion, when you have a proportion, you can cross multiply. This is when you cross multiply, right? So you're able to cross multiply here, and when you do, you can find out that in fact 2 times 12, you say, is that really equal to 3 times 8? And indeed it is, right? 24 equals to 24. So this is a way to check that this proportion is indeed true. Now, it's useful to use this measuring model to reason about it, okay? So another way that we can look at a proportion, so actually, let's see if we can just, well, I'll just rewrite it right here. So let's keep our 2/3 equals 8/12 as an example, right? Another way that a proportion works is if I look at the numerators, right? So that my numerators here are 2. My numerators here are 2 and 8. And I say, well, if I have 2, how many times bigger is 8 than 2, right? And we can say, actually, it's as if I multiplied 2 times 4, right? So if the numerators are 4 times bigger, indeed, the denominator is going to be 4 times bigger, right? And in fact, 2/3 we said was equal to 8/12, right? That got erased, right? And so this is also another way that proportions work. And we can reason about this way of looking at things using the measurement model. Okay, so we had 2/3 is equal to 8/12, right? And so we can interpret this actually as a length. Remember, we can interpret any fraction as a length measured with a ruler, right? So we can kind of think about it as a length. Let's say I have a 2-foot bar, right? So this is 2 feet long. And let's say that my ruler is 3 feet long, right? It's 2 measured in units of 3, right? That's what we're saying. We can even be fancy and go, this is my 2. So this is my length here, 2 feet measured with a ruler, right? That is 1 to 3 feet long. We say, okay, so how many is this going to take? There's 1 foot, 1 foot, 1 foot. And in fact, it would take 2/3 of the ruler, right? 2/3 of the ruler to measure that 2-foot length or whatever, right? Well, look, we can do the same thing now with this 8 and this 12, okay? So we can say, well, now instead of a 2-foot length, what about, right, if I have an 8-foot length? So we can imagine here's my 8-foot length. There it is. And now my ruler is 12 feet long. Oh my goodness, my ruler now is like way bigger, right? So again, here, if I wanted to do it, I could say 1, 2, 3, 4, 5, 6, right? I could say these are all my 12 feet is right here. So this is all 12 feet. And my bar that I'm measuring, my length that I'm measuring, this is 8 feet. And we can ask the same question, right? How many rulers would it take to measure this bar? And you're going to get the same answer. It would take 2/3 of this ruler, right? In the same way that here it took 2/3 of the ruler to measure the bar, right? And so this just gives you a sense of really what we're doing when we are dealing with a proportion, when we're working with a proportion, is, believe it or not, it's sort of like pinching your phone, right? We're sort of expanding. We're sort of making bigger, dilating. So for example, we have this triangle, right? And you can see that if you just sort of make it bigger, everything is getting bigger, but what's important is it's getting bigger at the same rate, right? So maybe the base of the triangle is getting bigger, the height of the triangle is getting bigger, but they're both getting bigger at the same rate. So if one gets 4 times as big, the other gets 4 times as big, just like what we saw. Okay, so let's do a very quick and a very easy example, one that I bet you could all do in your head, right? At a store, you can buy 8 cookies for $20. How many cookies can you buy for $10? Right? Of course, 4, right? Because what you probably did in your head was you said that 10 is half of 20, so I should be able to buy half of 8 cookies. That's proportional reasoning. That's exactly what you did, right? You said that there were $20 for every 8 cookies. How many, or you said, so if $20 buys 8 cookies, $10 buys how many cookies, right? And you say, oh my gosh, now we got to cross multiply, and you spend you don't have to necessarily spend all of this time doing this cross multiplying, right? So what would that look like? 20x equals 80, and then we have to divide by 20, and divide by 20, and we're going to end up with the answer that was so intuitively obvious just from the question, right? So you don't actually have to cross multiply every time you see a proportion. Sometimes it makes sense to reason just the same way you reasoned initially, by saying that if I go from 20 to 10, what am I doing? I'm really dividing by 2. 10 is half of 20, so 8 divided by 2 better be 4, and indeed it is, right? So that's sort of the power of proportions. So I encourage you, while it's always tempting, you can always cross multiply. This is true. I encourage you to, before you do that, think about how do the numerators relate to each other, and that relationship, that multiplicative, either multiplying or dividing, that relationship on the numerators is going to be the same as the relationship on the denominators, right? We can say, for example, x over 5 equals, let's say, what do we want to say, 22 over 10, right? Say, oh my gosh, now I got to multiply, divide. This looks like such a mess. No, you don't. To move from 10 to 5, I divide by 2. Or if you don't like that, right, you can also say to move from 5 to 10, I multiply by 2. So to move from what number would I multiply by 2 and give me 22, right? 22 is twice as big as what number? X equals 11 is the answer for this simple proportion.